China is building some of the most advanced deep-sea technology in the world, leaving the US engineers stunned. China has invested heavily in vessels, submersibles, robotics, canal systems, and engineering platforms that operate thousands of meters below sea level. Now, these projects focus on science, energy, transportation, and strategic capability. The goal is long-term ocean access with reliable infrastructure that supports research, resource study, and maritime development. One of the most important additions is the experimental research vessel known as Future. The vessel was delivered in late 2025. That project was developed by the Taihu Laboratory of Deep-Sea Technological Science in partnership with China State Shipbuilding Corporation. The vessel works like a floating laboratory at sea. The design supports equipment testing, deep-sea surveys, and system verification for new underwater technologies. The vessel is about 110.8 meters long and 20 meters wide, and it weighs around 7,000 tons. It can travel at a speed of about 15 knots. The ship can sail up to 10,000 nautical miles without needing to refuel. It can carry around 80 people, including crew members and scientists. The vessel is built for global travel. Engineers added smart control systems to manage power use and onboard equipment. The design also focuses on saving energy and using modern digital systems. The purpose of Future is practical. Researchers test deep-sea robots, pressure systems, sensors, and communication tools before deployment into extreme environments. Scientists also conduct marine geological surveys and environmental observation missions. Data collection supports the mapping of seabed terrain and mineral deposits. Teams can operate for extended periods because the vessel carries advanced laboratories and testing facilities. China has also expanded its infrastructure that supports deep-sea operations. One example is the Suo San Hao, also known as Exploration No. 3. The vessel entered service in December 2024. The ship operates under the Institute of Deep-Sea Science and Engineering at the Chinese Academy of Sciences. The platform supports manned submersibles and heavy deep-sea missions. Suo San Hao measures roughly about 104 meters in length and 19.7 meters in beam width and weighs about 9,300 tons when fully loaded. The propulsion system uses diesel-electric engines combined with azipod thrusters, and its range extends to roughly 15,000 nautical miles. The ship can accommodate around 80 people, including crew and scientific staff. The structure includes a moon pool that allows safe deployment of submersibles directly through the hull. One of the most advanced is Fendouzhe, also known as Striver. Fendouzhe completed dives to depths exceeding 10,000 meters. The submersible reached Challenger Deep in the Mariana Trench at a depth of approximately 10,909 meters. The design allows 3 scientists on board during missions. The pressure hull uses titanium alloy materials to withstand extreme deep-sea pressure. Fendouzhe continues scientific missions that study deep-sea biology, geology, and mineral resources. Researchers collect sediment samples and observe life forms that survive under extreme pressure and low temperature. Each dive adds valuable data to marine science databases. The missions also test communication and navigation systems at Hadal Zone depths. China has also built more manned submersibles to increase its deep-sea strength. The Jiaolong reached depths of more than 7,000 meters during earlier missions. The Shanghai Yongxi supports research at depths of around 4,500 meters. Together, China's manned submersibles have completed more than 1,700 deep-sea dives in different parts of the world. These missions have taken place in the Pacific Ocean, the Indian Ocean, and even in polar regions. Unmanned systems also play a big role in this process. Remotely operated vehicles, known as ROVs, handle tasks that require accuracy and long working hours underwater. One example is Haikin, developed by Shanghai Jiao Tong University. Sea trials showed that it can operate at depths greater than 4,000 meters. The vehicle collects samples from the seabed and sends back live video and sensor data to researchers on the surface. Engineers have also created advanced winch systems that work at full ocean depth. These systems can handle optical cables at depths beyond 11,000 meters and support loads heavier than 15 tons. Strong and reliable winches are necessary for lowering equipment, lifting samples, and keeping communication lines stable. Safe deep-sea research depends on these systems working properly. China has also tested the Pioneer 2 mining vehicle at depths of more than 4,000 meters. The machine can move across the seabed and drill into the ocean floor to collect mineral samples. The project focuses on studying polymetallic nodules and other seabed resources. Commercial deep-sea mining is still controlled by international rules, yet research and technology development continue. In addition to research vessels and submersibles, China is building major maritime infrastructure projects that support trade and economic growth. One key project is the Pinglu Canal. The canal is about 134.2 kilometers long and is under construction in Guangxi province. It will connect inland rivers directly to the Gulf of Tonkin and provide a shorter route to the sea. The canal must handle an elevation difference of about 65 meters between the inland waterways and the sea level. Engineers are building large lock systems to move ships up and down safely. The project requires massive excavation work involving hundreds of millions of cubic meters of earth. When finished, the canal will reduce transport distance and improve shipping efficiency for inland regions. Transportation efficiency improves because vessels no longer need to take longer routes through older river systems. Shipping time decreases and fuel costs drop. The project supports regional economic integration between southwestern China and international sea trade routes. Industrial supply chains benefit from faster movement of bulk cargo such as minerals, agricultural goods, and manufactured products. China already operates one of the world's largest ship lifts at the Three Gorges Dam. The Three Gorges ship lift can raise vessels over 100 meters vertically. The lift system uses a balanced counterweight design that reduces energy consumption during operation. That experience with large-scale ship elevation systems supports new canal and lock construction projects. Deep-sea engineering development also includes advanced testing laboratories. Large marine engineering test pools simulate offshore conditions. Facilities allow engineers to evaluate structural strength, wave resistance, and underwater robotics before field deployment. Testing centers reduce risk during real ocean missions because systems undergo controlled evaluation. The deep-sea sector continues to grow as part of the long-term national marine strategy. Ocean science contributes to climate research, seabed mapping, and resource evaluation. Fisheries management benefits from improved monitoring tools. Offshore renewable energy projects require strong support from marine engineering. Deep-sea cables and communication lines depend on accurate seabed surveys. Green technology has become an important part of vessel design. Hybrid propulsion systems reduce fuel consumption, and the intelligent navigation systems optimize route planning. Digital monitoring platforms track energy usage in real time. Global competition in deep-sea technology is growing because ocean resources and sea trade are important for many countries. Each mission improves safety and engineering quality. Teams improve how they launch submersibles and ROVs, and they upgrade hull strength based on data from earlier dives. Engineers design equipment to survive high pressure, salt water, and extreme cold. Strong materials and reliable communication systems are essential for deep operations. Modern vessels like Future support ships such as Suo San Hao, and submersibles like Fendouzhe work together with advanced ROVs and large canal projects to form a connected maritime system. Each part supports the other and improves overall capability. Deep-sea technology now goes beyond simple exploration. It includes shipping, energy research, environmental monitoring, and advanced robotics. Progress continues through steady investment and strong engineering standards. The momentum behind these projects signals that deep-sea exploration will remain a central focus for China in the coming years.